Welcome and hello. This is an exercise video in EPANET titled Comparing Costs Between One versus Multiple Pumps. In this exercise, we'll compare the cost of pumping for a network that uses one pump and then that same network when running multiple pumps. So what I have on the screen here is my EPANET. Let's go ahead and get started. I'm going to start with a reservoir and I'll put it right there. And then I'm going to add a tank, put it right there, add a junction and put it right there. Okay. I'm going to connect the tank to the junction with a pipe. So that'll be right there, P1. And then I'm going to start with my large pump first. After that, I'll add multiple smaller pumps. So the large pump is going to be from R1, the reservoir, up to the tank C1 right there. And now I will start defining the properties of the objects in my network. I'm going to click on the select object tool and then let's start with the reservoir. So opening up the properties here, I'm going to go with a total head of 0 feet. This model is going to be using English units. Okay, so 0 feet, that's fine, nothing to do there. Next, the pump. I'm going to rename this pump. Currently, it's just PMP1. I'm going to call it PMP underscore B1. Okay. And then further down, I'm going to define the pump curve, or at least specify the pump curve that this pump is going to use, CRV PMP B. And then I'm also going to set the pump curve efficiency, which is further down, efficiency curve right here. That's going to be called CRV EFFB, which is the efficiency curve for pump B. Before we do anything else, let's go ahead and define those two curves, and then we can resume setting up the data for the tank, pipe, and the junction. So over here in the data browser, I'll click on curves and then click on add new curve. For the curve ID, let's take care of the pump curve first. This is the ID that I set. So the curve type is pump, that's already good. And then for the flow data, I'm just going to type in a range of flow rates. So 0, 200, 400, 600, 800, 1000, 1200, 1400, and 1600. Okay, so then over here, the head is going to be 120, 118, 112, 102, 88, 70, 48, 22, and 0. Oops, 22. There we go. So that is the pump curve. And then I'm going to click on OK. Now I'm going to define that efficiency curve, which is going to be for pump B. So it's going to be called, the ID is CRV underscore EFF underscore E. And then the curve type is going to be efficiency. And I'm going to use the exact same flow rates I did previously. So 0, 200, 400, 600, down to 1600. And then the efficiency values are as follows: 55, 68, 78, 84, 82, 75, 60, and 35. All right. And okay. Okay, so our pump is set and ready to go. Let's resume with editing. Let's go with the tank now. So opening up the tank properties, P1, it's going to have a base elevation of 70 feet and then an initial level of 10, minimum of 0, max of 20, and then diameter will be 60 feet. The junction J1 will have a base demand of 400 gallons per minute, and it's going to have a demand pattern RES. This is residential pattern, so let's go ahead and define that now. Over in the data browser, I'll click on patterns, new pattern, the ID will be RES, and then I'll navigate to that pattern file, which is right here. So if you want to use the same numbers as me, here are the multipliers, 1 through 12, and then further over we have 13 through 24. I'm using a 1 hour time step for the patterns, so that's ready to go. Click on OK and yes. And the last thing to make edits to in the physical objects is the pipe. P1, it's going to be a pipe that's 1,000 feet long, and the diameter will be 24 inches. Really not too interested in the junction or the pipe. I'm more interested in the pump as well as the energy required to operate the pump. Speaking of the pump, let's take a look at the tank now. We have a base elevation of 70, and then the total height is from 0 up to 20. That's the min level to max level. Let's go ahead and create some controls so that this one and only large pump will pump in the tank and turn on when the level's down to 5, and it'll turn off once the level's up to 15. So we're not using the bottom 5 feet or the top 5 feet for this specific operation, but we could if we needed to. All right, so to do that, I'm going to go over to my data browser, click on Controls, boom, and then open up the simple controls. So double click, and then I'm just going to paste in the controls I already have prepared. It basically says to turn on if if the tank T1 is below 5, and then the pump should turn off, i.e. 0 here for the status, if the tank T1 is above 15. Cool. So click OK. And then lastly, in the data browser, I want to set a few options. First, the time options. This is going to be a 10-day simulation, so we'll type in 240 hours for the total duration. And then for the hydraulic time step, I'll say 5 minutes, and the reporting time step also 5 minutes. Go down to the energy options now, and then what I'm going to set is 75% for the pump efficiency. Now, this is going to be ignored because we already have efficiency curve assigned to our pump, but we do want to put in a energy price. I'm going to type in 0.15. So that will be like US dollars per kilowatt hour. And we are ready to go. Let's go ahead and run the model and see what happens. So save that and execute. All right, the run was successful. Let's check out some of the results now. I'm going to look at the time series plot of the tank head. So I'm going to report, graph, and then I already have time series selected. Tank is T1. That's the node ID. And then for the parameter, I'll click on head. So what we're seeing here is over the course of 10 days, the water in the tank oscillates between 75 and 85, which remember is a level of 5 feet and 15 feet, since the elevation of the tank is at 70 feet. It looks like the pump turns on once or twice per day, just counting how many times the level of the tank goes up and down over 10 days. Let's take a quick peek at the pump. So let's click on the pump, and then I want to look at the flow through the pump. So I'm going to open up the graph. We have link, we have the pump, and then the parameter of flow is right here. All right. So as you can see, the pump is turning on and turning off over the course of the 10-day simulation. If I right click and we can zoom in on the horizontal axis here. So let's do that with a grid line every 2 hours. Boom. So this is the very beginning of the simulation. The pump turns on and then it turns off right here. And then it's off from about 2.5 hours to almost 12 hours. Then the pump turns on again and then it turns off. So judging by this, I'd say the pump is probably off a little bit more than it is on, but not by too much. And finally, let's take a look at the energy report. So I'm going to go up to report and then energy. And then here's what we have. We have a single line item here for our pump B1. This is our big pump. It looks like 44.8% of the time the pump was on. So that's consistent with what I expected from the pump slot. And then over here on the far right is the cost per day. It says it's $26.05 to operate this pump every day based on the price that we told it, as well as all the other inputs like the flow rate and the head. And we also have an average efficiency right here of 83.15. That's in the percentage. So that's pretty good. That's actually very good because it happened to be right near the top of that efficiency curve, which is based on the head and the flow rate. Okay. So we're going to go ahead and remember this number, 26.05, as well as the percent utilization and the average efficiency. And then what I'm going to do right now is create a few other pumps. They're going to be smaller pumps from R1 to T1. They're going to have separate pump curves and efficiency curves. And we're going to compare how the energy results from our big single pump one that we just executed and looked at the results for compare with multiple smaller pumps. So before I forget, I'm going to close this pump here so it doesn't interfere with the operation that I'm going to perform next. So that's out of the way. Next, I'm going to click on New Pump and then add 3 new pumps from reservoir R1 to tank T1. So here's the first one, boom, PMP1. I'll probably have to rename these. And then here's the second pump, and then the third pump right there. Okay, so let me zoom in so I can see what I'm dealing with a little bit better. I'm going to call these pumps PMP S1, 2, and 3 for small 1, small 2, and small 3. So the first one is S1, and then number 2 is going to be S2, And then number 3, PMP3, I'll switch that to PMP underscore S3. There we go. Now I do want to assign a different ID for both the pump curve and the efficiency curve. So let's do that. The pump curve is going to be CRV underscore pump S. And then the efficiency curve is CRV underscore EFF underscore S. So that is set for my third small pump. I should be able to just copy those properties to the other pumps. Yes. And paste and paste. Okay, let's go ahead and define these two curves now. So starting with the pump curve for the small pump, let's close that, go over to curves and click on new curve. All right, the curve ID is CRV PMP underscore S. It is a pump curve. I'm going to type in a bunch of numbers again here. So bear with me. 0, 50, 100, 150, 200, 250, 500. Okay, so just every 50 increments in gallons per minute. Then the head is going to be slightly decreasing. So 110, 108, 104, 98, 90, 83, 75, 60, 40, 15, and 0. Oops. Let's see. That goes there and good. Okay, so that is the small pump curve. I'll click on OK. And then one more curve. This time, this is the efficiency of the small pump curve, of the smaller pump. So I'm going to use the exact same flow rates as before. So just 0 up to 500 every 50. Okay, there's 500. And then the efficiency numbers are 0, 52, 66, 76, 82, 85, 83, 76, 65, 45, and 25. Okay, very cool. And okay. Now, the last thing we need to do before running the analysis is to set the controls. So let's go to controls, and I'm going to use simple controls again. We don't want to use the same controls as before, but boom, these are the controls I'm going to use this time. Pump 1 is going to turn on if the water level gets below 9 and turn off at 15. Pump number 2 is going to turn on if the water level gets below 7 and then turn off at 13. And then pump 3 is the lowest pump. It's going to operate between levels of 5 and 11. So as before, we're covering that range between 5 and 15, but I've got the pumps staggered a little bit just to mix things up. All right, I'll click on OK, and then let's go ahead and run the analysis. So project, run analysis. This is 240 hours of data. So this is successful. That's 10 days. Let's take a look at the same data that we looked at before with the one big pump. And starting with the head at tank 1. All right, here is the water level in the tank. It starts at 80. It goes up to about 83 and a half, I guess, and then down to 76 and a half. So it never actually gets all the way down to 75, which would be the 5-foot mark. And it looks like it never actually gets up to 85 either, which is the 15-foot mark or 15-foot level. So I suspect that one pump will always be on, and then I think pump 2 is kind of toggling on and off. We can don't have to guess about that. Let's take a look at the pump graph. Okay, so this is the pump graph for the one big pump. I do need to recreate this graph. So let's click on how about pump 1, the first small pump report graph. Then I'm going to add pump 2, the second small pump, and the third small pump time series, and I want to select a flow from my parameter and open. All right, so what we're looking at here is the flow rate through the 3 pumps. I'm going to actually toggle on the check boxes, which is in the graph options. To open the graph options, you can just right click on the graph, or you can come up to report and options. And then you want to click on the, let's see, I think it's the legend tab. Yes. And then click on check boxes right here. This allows you to toggle on and off the different series data. So what it looks like is pump 1, this first small pump is in red. This one's always on. Okay. And then let's see, the green is sometimes on and sometimes off. That's pump 2. And then the purple line is unfortunately always off. I guess I didn't even need to do that, but if we had higher demands, then we know that pump 3 was on standby for us and would be able to accommodate some additional flow. So what we see here is always on, sometimes on, and never on for my pumps 1, 2, and 3, the small pumps. Let's take a look at the energy report. So we can minimize that. Report energy. This table shows a row for each pump, including our big pump that just isn't on at all. Pump 1 is on 100% of the time. Pump 2, the second small pump, is on 44% of the time, and then pump 3 is on, looks like it's on 0.24%. So that might, maybe it just toggled on for one time step at the very beginning. That's my guess. Otherwise, I'm not exactly sure what's going on there. Efficiency is also very high. We have 84, 83.8, and 84. So that's encouraging. And then as for the cost, $17.45 for the small pump that's always on, $7.87. This is per day for the second small pump, which is on 44% of the time, and then sort of a trivial 4 cents, pump 3, totaling $25.36, which is almost the exact same price as this one single large pump, which was $26.05. So about 70-cent difference. And I'm really not surprised with that small difference because the demand hasn't changed. So we're pretty much pumping the same amount from the reservoir up to the tank, whether we're using one large pump or multiple smaller pumps. Head really doesn't change too much. The flow rate does change, but that's on a per pump basis. Overall, the flow rate wouldn't really change. The efficiency was pretty much the same. They were both around 83, 84%. And then the last parameter was the density of water, which of course doesn't change either. So what's important here is when you're designing a pump for your pump station, you want to figure out, about how much head you're expecting to lift from the source to the destination. And then from there, figure out the pump that has a maximum efficiency for that head. And you'd also want to figure out how much flow rate are required of the pump or pumps as well. So if we want to go back to those efficiency curves, actually, let's first of all just take a look at this. We have the total head of 0 at the reservoir. Tank is going to be looking at a head between 5 and 15. So that would be put us at 75 to 85 feet of head. Now, if we go to the curves and let's look at the big pump first, 75 feet of head to 85 feet of head puts us around a flow rate of about a little over 800. We'll say 850 feet. So let's visit the efficiency curve. I guess I have to close that first. Here's the efficiency curve. Now we're looking at a flow rate of around 850, which is boom, smack dab in the middle of the highest efficiency numbers. So that's not an accident. That's sort of how you would want to design a pump. So the same thing is true with the small pumps, or it should be. So let's take a look at the pump curve first. Remember, the head is around 75 to 85 feet. So let's go down to 75 to 85 feet. We're looking at a flow rate of around 270 to 280. That's gallons per minute. So let's close that up and look at the efficiency curve. 270 to 280 on the flow rate right here puts us right in the highest location, highest efficiency on that efficiency curve. Say, for instance, that we picked the wrong curve or the efficiency was off. That would probably dramatically increase the price of pumping because the efficiency is off and you can do the math. So what I've done here as one final part to this exercise is to change the efficiency curve for the small pumps because that's what I already have enabled and the controls are already set up. So let me just change this a little bit and just type in some different numbers like 0, 10, 20, 35, 47, 57, 64, 69, 73, 75, and 76. All right, so the maximum efficiency is probably at 500 gallons per minute, or maybe even a little bit higher based on the curvature of the efficiency curve. We're going to be working in a flow rate of, what did I say, around 280. So that's going to bring the pump efficiency down to about 60. It was previously around 83. Let's see what happens when we run the analysis now. Okay, that's done. I'm going to skip straight to the energy report and we'll take a look at the numbers. Now, the flow rates and the utilization doesn't change much, 144%. But over here, the total cost is now $35.24. That's per day, which is a lot more than it was at $25.36. It's almost $10 more. So almost a 40% increase in pumping cost simply because the wrong pumps were chosen and the efficiency is so poor. So that's it for this exercise. We compared the price of pumping between one large pump and multiple smaller pumps.